I've worked on that too. That's so it's really interesting. Go ahead then.
Great, thank you so much. So my name is Dan Gottlieb. I'm a clinical informatician and software consultant. And for the last, I guess, 5 years since we started working on this API, I've been co-leading the development of the FHIR Bulk Data API with Josh Mandel. But I do want to make it clear, like this is actually the work of a lot of people in the FHIR community, as well as support from the Argonaut project members and the Smart Health IT project and HL7. So huge number of people contributed to the spec. So even though I'm kind of presenting it, it's really kind of a community effort. So I've given this presentation at prior DevDays conferences, and every year I kind of go through and update the slides with what's changed and new implementations. And so the presentation grows a little bit, but it's also really fun because you can see how things are progressing with the API. So even though I've given this before, I think this is going to be a little bit of a new presentation with some new information. So hopefully folks who have some experience with the API will find that interesting as well.
There's something in the screen.
Oh, yep. Can I get rid of it entirely? Do I?
Think if you go up, yeah, and then click the dots.
Okay.
And then hide video panel first, and then you click that again, and then you click hide floating meeting control.
Ah, awesome. Thank you. There's always a Zoom issue. So we've gotten that out of the way early. So we have kind of a packed agenda. I'm going to try to go through as much of this as we can, but as I mentioned, I add to the presentation every year without cutting things really, so it grows and grows. So we're going to start by talking about why we developed the FHIR Bulk Data API and kind of some of the use cases it makes sense for. We're going to talk about, we'll dig into the technical architecture a little bit and kind of talk about the request and response flows. And as we talk about that, I'll highlight the things that we added in version 2.0, which came out a little over a year ago. I'm going to talk about open source tools that are available for building on top of the API and testing your implementations. We'll talk about adoption. That's my favorite part. And then we'll talk about next steps and some related projects if you're interested in kind of building on top of the bulk data. I have a URL for the slides there. I'll post that again at the end, so don't worry too much about grabbing it right now. And the slides, I think, are also up on Whova. So when I think about FHIR data, I kind of usually, or any clinical data really, I think about kind of 3 levels of data. So the smallest data set would be data on a single patient. And so if you think about a Smart on FHIR app that might be like a risk calculator that's embedded in an EHR, it's using the FHIR API to pull in just data on that single patient that's being accessed through the EHR system. And that's not a lot of data. And so the FHIR REST API, kind of the standard FHIR API, works really, really well for that use case and is very efficient. And then if you go one step bigger, you start to think about the panel of patients a healthcare provider might see. So you might have 1,000 patients or up to 2,000 if they have a big panel. And so if we imagine that same risk calculator, but now you want to rank your patients by a particular risk score so you can reach out to patients who are in need of care. That's kind of panel level data, and the FHIR REST API works okay for that, but you have to start being a little bit clever about restricting your API calls with filters and limiting the data that comes back using things like the elements parameter in your searches. And so you can make that work reasonably well. But then when you start to get to kind of population level data, so you want to transfer your data on a large number of patients into another system, you want to send data to a registry, that's where the FHIR REST API starts to break down. It wasn't really designed to pull data on thousands of patients or hundreds of thousands or even millions of patients. And so that's where we really started. That's why we developed the FHIR Bulk Data API, to be able to target those types of use cases using FHIR. And there are a lot of those use cases. So I won't go through kind of all of the use cases on the slide in the interest of time. I wanted to highlight a couple that I've worked with in my career a little bit. One that's really common on the research side is taking data from one or more electronic healthcare systems for a cohort of patients, putting it in a research database, and then running analytics, building models on top of it, that sort of thing. And so that's a really common use case, and one of the things we really tried to make sure works smoothly with the FHIR Bulk Data API. Increasingly, we're seeing folks trying to train machine learning models on healthcare data. That's another case where you might want to get large amounts of data out of your clinical systems into some system that's better for kind of working with it from a training perspective. And then a use case that I really like, and we'll touch on this again towards the end of the presentation, is not getting data out of clinical systems, but bringing data into clinical systems. So a really neat thing you could do with a bulk API is take claims data from payor organizations that have kind of data from multiple healthcare sites and bring it into the electronic healthcare system at a single site, so that providers at that site can get kind of a 360-degree view of the patient and really understand if they're getting care outside the system. So a really common use case for this might be a flu shot, where a patient might get it in a pharmacy. The provider doesn't know if their high-risk patients got flu shots, but if you can bring the claims data into the electronic healthcare record, then they can see which patients got flu shots and which patients might be missing that and reach out to them or do other interventions. So lots of really neat use cases with moving data around using the FHIR Bulk Data API. And when we designed the API, it's really not that much new stuff. We took really a bunch of FHIR components that already existed and tried to put them together in a slightly different way to better support this use case. So we're still using FHIR resources as the data model. So hopefully folks are familiar with the FHIR resources. If not, I'm sure there are videos on Whova you can kind of go back to. But the neat thing is that the FHIR Bulk Data API is really kind of data agnostic. So if you need to transfer payment data through claims resources, you can do that. If you want to transfer clinical data, which is kind of what a lot of our initial use cases are, you can do that as well. So it's really FHIR resources are the building block, but not any particular set of FHIR resources. We leverage the FHIR operation API to be able to initiate and manage your bulk data exports, well, really kick off your bulk data exports. And so that means that kind of if any system you go into is going to have the same way of starting an export, which is different from kind of how it's been historically, where you might be exporting CSV files from different systems, and those will operate in totally different ways depending on the system and the site. And similarly, we use Smart Backend Services Authorization as a security model. This is a flavor of OAuth for machine-to-machine communication, and I'll talk a little bit more about the details of that at the end of the presentation. But again, the neat thing is that if you're collecting data from two healthcare sites, both of them will have the same auth flow instead of having kind of a custom approach for every export. So I think it's also really interesting to talk about kind of what's not currently in the bulk data spec. So there's a couple things that we decided were out of scope initially, and I think it's worth reviewing these. So one is this is a technical specification for kind of how to move data from point A to point B. So it assumes that both parties, the party sending the data, the party sending the data and the party receiving the data, have an agreement and have the right, the receiving party has the right to access this data. So if there are other agreements that need to be in place, like business associate agreements are used in the US, or service level agreements or data use agreements, all of that needs to be in place. And there's actually a stage in the authorization flow, and I'll mention this when we go through it, where there's a good place to check that those agreements are in place before authorizing an application. The bulk spec is also kind of designed around batch transactions. It's really, I often think of it as replacing kind of CSV exports and imports rather than kind of streaming or real-time data. That said, you can kind of get at some of those use cases using other FHIR building blocks. So if you imagine doing kind of a bulk data to backload data into a care management system, you might do that on a nightly basis, but then when a care manager pulls up an individual patient, you could do a regular FHIR REST query into the source system to see if there have been kind of any visits in the last day that might update their data. So there's ways to kind of combine bulk exports with regular FHIR REST API calls to handle those use cases. Another really interesting way that you might kind of handle more real-time integrating more real-time data is to use the FHIR Subscriptions API. So Gino gave a talk on that yesterday, definitely worth checking out. And so that would let you be notified as data updates kind of between your bulk loads. And so you could, your app could kind of handle some of those situations. Patient matching is another thing that we've kind of left mostly out of scope. So if you're importing a bulk data set and you already have patients in a data warehouse or on your side, you might need to match those patient IDs to be able to integrate the data together. And so that's something we don't directly address in the bulk API, but we do support kind of, so if you're doing patient matching using things like demographics or subscriber numbers, all of that data can come through in patient resources in the bulk data export. So you can still use kind of the standard patient matching approaches with the bulk data export. There's just nothing kind of specifically tailored to that. And similarly with data transformations, the bulk data API is going to export data in whatever format the source system is putting it out. So if they have a particular code system for labs, those are the codes that'll be associated in the FHIR resources. You may need to transform those codes, for example, to something used in a different country or something used in a different system. And so I often think of bulk data as the first step in a data pipeline, where you might do some of those transformations as kind of the next step in your data pipeline. And I'll talk about some of the other pipeline tools that are starting to become available for bulk data. But often you might need to do some transformations on your data as part of the import process. That's not directly handled in the bulk export spec, but is something you can easily kind of integrate with a standard kind of data pipeline orchestration tool. So let's shift gears a little bit and kind of talk about the actual flow in a bulk data export. There's two versions of bulk data. I think I mentioned this kind of initially. There's version 1 that was published in August of 2019. And then we went back as folks started implementing version 1, we realized that there were some things that could be improved. And so we went back and did a version 2, adding some of those additional features, generally around performance. And so I'll highlight some of those as we go through. I will note that version 2 is fully backward compatible with version 1. So what a lot of implementations have done is taken pieces of version 2 and added them rather than kind of implementing the full V2 spec, which is certainly fine. So if we're going to talk about the request flow here, on the left side of the screen is the bulk data client. So this is the system making the request to get the data. On the right side is the server. So this is the system that has your bulk data that you're trying to get. When we say client, I often think of a server that might be running a cron job on a nightly basis to pull in updated bulk data. So it doesn't have to be kind of a user-facing application there. It could be, it probably is more likely a server that's pulling this data. And so it's bulk data request starts with a kickoff request. There's 3 types of requests that are supported currently in the bulk data API. The first is a patient level export. So this by default will export all the data in the patient compartment in a FHIR server. And so all data on all patients in a FHIR server, although there's some filters that we'll get to in just a sec. Second type of operation is an export on a group of patients. So what we do here is we leverage the existing FHIR Groups API to kind of bucket patients in different ways. So if it's a pure FHIR server, it might support a way of kind of creating groups using a FHIR REST API. And then once you have that group created, you can, of course, list the groups using a FHIR REST API, and then take the bulk API to say, OK, here's a group of patients that's been defined using FHIR. Let's export all data on those patients. For an EHR FHIR server, there might not be a computational way of defining those groups of patients. It might really be a UI inside the EHR where you create a registry of patients. And then the EHR exposes that as if it was a FHIR group that can then be pulled out using the bulk export API. So that's the other pattern that we've started to see emerging. And then there's a third type of operation where you can do a FHIR export of all data on the server. This is kind of similar to the patient level export, but we'll get additional data like value sets and things that aren't directly associated with patients. And so that's kind of a lightweight way to do a backup of all the FHIR data on a server by doing that sort of export. I think the really key thing to understand, if you don't take anything else away from this around bulk data, is that the difference from the REST API is that it's fully asynchronous. So instead of kind of making a data request and getting back some data, you make a data request and you get back a pointer to a job, and then you can pull that job, and eventually you get your data. And that's the reason for that pattern. I think it's pretty obvious, but it's because a lot of these can be very large data sets, and it might take a server a while to pull that data together. In version 1, we only supported GET operation requests, and in version 2, we support HTTP posts as well. But they're both async operations. There are a number of parameters you can pass into your export operation to kind of limit the data returned or shape the data returned. First is output formats. So servers could support different formats for serializing the FHIR data. As under the spec, NDJSON is the required format, so all servers have to support NDJSON, which is a text-based format, and we'll look at an example of that kind of when we get to that stage of the flow. But servers could also support other formats like Parquet, which is a binary format for the data, although I'm not aware of any servers that currently do. A really key really key parameter is _since. So this lets you only request data that's been modified since a particular timestamp and a date time. And so that's important if you're doing, for example, nightly exports and want to get everything that's changed since your last export. So that's a common pattern: nightly, weekly, monthly exports, and only looking at what's changed. The _type parameter lets you filter by resource type, FHIR resource type. So if all you need is patient demographics, of course you don't have to get the full clinical record for a patient, and so you can filter there. The type filter parameter is a really neat parameter that we thought wasn't going to be widely supported, but is increasingly available in servers. And this lets you take any of the FHIR REST API filters and apply them to your bulk data set. So you could filter, FHIR observations by particular lab codes and get back a much, much smaller data set than you would otherwise. There are a bunch of parameters we added in version 2, and most of these are around kind of limiting the data returned in other ways, in case you have a use case where you don't want to load kind of a full data set. We support the we include the _elements parameter from FHIR, which lets you specify kind of top-level elements to return in FHIR so that you don't have to get the whole resource if you only need a couple fields. We support the patient parameter, which lets you specify a list of patient IDs to return data for. So even within a group, you can actually specify a subset of the patients in the group that you're interested in getting data for. So this is another way to kind of filter the data without having to create a group for every request. And then the last parameters include associated data. This is a parameter to let you specify what data you want on the resources that are coming back. So one of the things that came up with some of the work to support US government data sets or required data sets in FHIR was they require support for provenance resources, which is metadata about the resources that are coming back. And so we added this parameter to let you specify that I only want, the most recent audit record for a particular resource, or most recent provenance record for a particular resource, or I want all of them for these resources, or I don't care about that, just give me the data and not the metadata. So, and that's extensible as a value set. So if you have a server and there's additional metadata that some of your users might want about the resources, it lets you specify what to include in addition to the data that's coming back. Okay, so that was a lot about the kickoff request, but we got to the second arrow. So we made this request, and what we get back is a content location. It's going to be in a header and look something like this. You'll get a 202 accepted. The server has received your data request, and it's going to tell you where to look for updates on the status of that request. Of course, you could get an error at kind of any stage in this as well. So if you're building a client, you need to be able to handle that. So we take that URL, we hit it to see what's going on with our request, and we'll get back a status from the server. The status will look something like this. It's, again, a couple headers and potentially an operation outcome in there. And so we're still 202 accepted, so our request is still being worked on. We get an X-progress header, and so this is a text-based header. It's really for kind of logging or understanding where your request is. It's not meant to be machine readable, and different systems will handle this in different ways. So the server may or may not actually know that much about where it is on your request, depending on how it farmed out the job. And so it could say something like 50% complete. It could say something like 12,000 resources compiled. It could say 12,000 of 100,000 resources compiled. It really depends on what the server author is able to offer. So I would use this for logging, but not necessarily expect to have kind of something computational off of that. On the other hand, servers can also provide a retry after header, and this is computational. This is a standard HTTP header, and here it's in seconds, although I think it can also be a date time. And so it's saying, I suggest you retry this request after 120 seconds, after 2 minutes. So this is a hint from the server about how long it thinks it's going to take to process this request. So let's say we wait our 2 minutes here and we make another request to, again, to the same status URL location. We'll get back a response. If the request was still in progress, we'd get another in progress response. But here we're done. So what we do is we get back a status complete manifest. So this tells us kind of that the request is done and also some metadata and then our files. So I'm going to go through this kind of quickly, but I wanted to highlight a couple points. The numbers on the left are what I added. The actual response is a JSON response. So you get a transaction time, which is the server's timestamp for kind of as of date for the data that came back in this request. And so if you remember the since parameter, where you can request data only modified since a particular time, this timestamp gives you kind of your input for the next request to say, here's the, I want only data since this time in the server. It mirrors back your request. We've kind of deprecated this, so this is probably going to go away in a future version. It gets complicated with post requests where you have parameters that wouldn't be reflected back there. There requires access token. I'll talk a little bit more about authorization in a minute, but what this tells you is whether you need an auth token to retrieve the files. So some servers are using what's known as capability URLs, which is high entropy URLs, to retrieve the files, where you wouldn't need the client necessarily to reauthorize to pull down those files. And so in that case, requires access token would be false. But if the same authorization that was used in the request is needed when you retrieve the files, then this would be true. And then kind of this number 4 there, I should be saying the numbers. Number 4 is the output section of this manifest. So this is kind of the bulk of it. These are the files that have your actual data in them. And you see the resource type for each file. You can have multiple files for the same resource. So here we have 2 files of patient data and 1 file of observation data, observation resources. But you wouldn't, according to the spec, you can't mix resource types in a single file. So each file will be 1 resource type. And that was kind of at the advice of some folks who were doing a lot of ETL work and thought it was much simpler to kind of ETL different types of FHIR resources using different, if they're in different files. It's really up to the server how to break up the files, though. So here we have 2 patient files. So some servers will return very few, very large files, and some servers will return more slightly smaller files. So it's up to the client to kind of be able to handle multiple files per resource type of different numbers of resources per file. This number 5 there is the deleted key. We added that in version 2. And if you're doing a request post a transaction time, the server has the ability to communicate resources that were deleted prior to that time in the server. So if you're doing kind of serial requests where you might get all your data updated after a particular date in Sint, the server can say, hey, I know that after this date, I deleted this patient who was there before the date, and communicate that to the client. So this is not designed for logical deletes. So this you wouldn't necessarily use this if a lab was entered an error. You would just change the status on the lab and resend it as modified data. But if a patient was sent an error, so a patient was sent to a client that shouldn't have been sent, this can provide a signal to the client that it should delete these patients from downstream systems. And then the last key is kind of misnamed. We called it error, but it's actually kind of any operation outcome. So some of those could be informational as well. So if there was a problem processing this request, the server could communicate it there, or it might communicate kind of metadata and say, hey, I didn't give you these resources because of privacy or other things. I subsetted the data. And so that would be an informational operation outcome. So if the operation went really badly, the server could just return an error entirely instead of the status complete response. So it could return an error header and an operation outcome. But the server also has the option of kind of putting some of the errors into this NDJSON file of operation outcomes if it doesn't want to fail the whole operation. So you could think about if you're retrieving data on 1 million patients, maybe there were problems with 2 of the patients. The server might not want to say, hey, start your entire request again. Instead, it might just put some operation outcomes indicating that it couldn't retrieve data on those 2 patients in this request. So it's really up to the server whether to put errors here or fail the whole operation. So kind of the next step a client would do is retrieve the individual files from the server. That would be for every file in that array, as well as any of the operation outcomes and information on the deleted patients. I mentioned I would talk briefly about what an ND-JSON file looks like. This is really it. So it's pretty straightforward. Here I've crossed out the things that might be in a normal JSON response, like a FHIR bundle, which is basically any of the surrounding data. Instead, in ND-JSON, you just get one FHIR resource, one JSON object per row. And this has a really neat property of letting you read and write these files in a streaming way without having to load the full file into memory. I'll also note that they compress super well. It looks very repetitive on the text side, but of course all of that compresses out if you gzip the file, and gzip interpreters are super fast because a lot of work has been done in that space. So if you're sending gzipped ND-JSON, it's actually not a terrible format for large data sets. I mentioned I would talk about authorization a little bit more. So Smart Backend Services authorization has kind of two steps. The first step is a registration step, where the client registers its public key with the server. And in return, the server gives the client back a client ID to use in requests. And then when the client wants to make a request, it signs a token request using its private key, sends that to the server, which verifies it using the public key, knowing which client it is based off of the client ID, and sends back a token. And so this is a very lightweight request that doesn't require any user interaction when it's set up. So if you're checking kind of agreements, you would do that at the registration stage, issue the client ID, and then subsequently there's kind of no human interaction. And because some of these requests may take a long time, some of the EHR requests have been taking days, the client will probably have to request a bunch of tokens kind of throughout the process. What it'll do is every time it gets back an unauthorized response, it'll request a new token and then resend the request with the new token. So all those requests that we talked about, of course, have authorization headers on them and kind of follow this authorization flow before making those requests. From a security perspective, it's recommended to use short-lived tokens, but the token request process is very lightweight. So looking at this visually, there's kind of that setup step where the client registers, we check agreements, we decide if we're going to share data, and then there's the ongoing kind of pre-request or if the token times out, where the client will sign a token request and get back a token, and that's fully machine to machine. So we went through that flow. I know it's probably a lot if you haven't seen it before, and it was also somewhat high level. If you're interested in kind of going step by step, I put together a Python tutorial in a notebook that kind of builds a very rudimentary bulk data client step by step. And so if you're interested, I'll put the URL to the slides, which have the URL to this tutorial. But that's a good way to really understand the flow at a very granular level. I'm going to skip this section on major enhancements in V2 just out of time, but the slides are in there. And so there were two things that are maybe worth looking at. One is around how you track whether members moved in or out of groups if you're only pulling data modified since this particular date. And the other thing we focused on was around handling of attachments. So making sure there was a way to retrieve attachments from FHIR resources. So if there's like a PDF document associated with a patient, the flow for being able to retrieve that in addition to kind of the resources in ND-JSON. Because I want to talk a little bit about the tools. There's a lot of really neat stuff that folks have built on top of the bulk data API. Probably one of my favorite tools is the reference implementation server. This is a tool that the Smart Health IT group at Boston Children's maintains. And it's a configurable server for bulk data. So this is not a production server. Please don't put this into production. But if you're testing a client, it provides a really neat way to configure the server to test different scenarios. You can even ask the server to inject errors at different points in the process. You can ask it to be fast or to be slow, to use different FHIR versions for the resources, to make a bunch of small files, a few large files. So you can kind of configure different scenarios on the server side to be able to really test an implementation that you're working on the client side. Let's see. There we go. The other thing that's, so I mentioned that I had this tutorial for building a bulk data client. If you're actually building you want to use a real client, the Smart team also maintains a reference implementation of a client. So this is a much more robust client, of course, that handles errors properly and has a bunch of configuration. So you can either put this directly on a server and kind of run it from a cron job if you want to pull down bulk data, or you can use it as a starting point to kind of build your own code on top of it. So it's a really good tool if you want to do real-world bulk data access to a server. The other thing that's interesting if you're building a server is the Inferno tool from the that's maintained kind of by or funded by the U.S. government, and so because bulk data is now required for EHR certification in the United States, or at least group level bulk data is, they maintain a tool for testing server compliance with that. There's also what they call the Inferno Community Edition, which tests the full bulk data spec, version 1 and version 2. So if you're building a server, these tools can really help you make sure your server's fully in compliance with the spec. Another tool that I built last year is a tool I call the FHIR Data Census tool. It's also open source. And this lets you take a FHIR bulk data export and kind of browse it to understand what's in it. So you can see kind of which fields are populated in this particular export. You can see what code systems are used, what terminology systems are used, what code values are used, how many elements are present, how many resources are present. So it's kind of a neat way to visually kind of understand what's in a bulk data export data set. So I want to talk briefly about adoption. I know I'm kind of running low on time, but I wanted to make sure we leave some time for questions. So when I started giving this presentation about bulk data, there were 0 implementations. And so it's really fun to be able to talk about how many implementations there are. There are a number of open source servers, including one from Microsoft in C#, one from Happy. The Happy server supports bulk data. That's a Java server. IBM, which is now apparently Merative, has a bulk data server that's also in Java that supports a lot of the V2 features as well. So that's really great. There are a lot of commercial FHIR servers, including one from FHIRly, our host for this conference. And then on the EHR side, because it's bulk data support is required for certification in the United States, many EHRs have added bulk data support in the last couple months. The requirement went into effect at the end of last year. Including EHRs from Epic, Cerner, and Meditech, which are, at least in the United States, kind of the three largest EHRs. On the payer side, CMS, which is the federal payer in the United States, has been an incredible early adopter of the bulk data spec for getting claims data to folks who need it. And so they have a number of pilot programs with real patient claims data for the federal coverage programs in the United States. That are sending bulk data today. And I'm actually I want to talk about one of those quickly because I think it's such a neat program. It's called Data at the Point of Care, and healthcare organizations can sign up to receive claims data via bulk FHIR for patients that they treat. And so as I mentioned kind of earlier, this lets them do that kind of 360-degree view of a patient, that's their words, where you can kind of get data on care patients are receiving outside your health system. So I think this is a really neat use case. We often talk about kind of ETLing data from electronic healthcare records, and this is data going into electronic healthcare records, or at least into care workflows from claims rather than all data kind of coming from EHRs. So I think this is a really neat use case. I want to talk very briefly about kind of next steps and how to get involved. So I think we're kind of pretty early on the adoption cycle here. Version 2 has been out for just a little over a year, but a lot of implementations are just starting to roll out now for bulk data version 1 and version 2. And so if you're interested, I really suggest you try to implement the APIs on top of your systems. You can implement bulk data on top of a data warehouse you have. You can implement a bulk data client if you're pulling data from electronic healthcare risk systems or some claim systems. And so I think it's kind of ready for implementation. It's being used in production in a couple places, mostly pilot-ish now because it's still pretty early days. And so good time to start using it. And of course, we're collecting ideas for version 3. There's already a couple kind of open tickets on the FHIR tracker for features that folks want to add in future versions. And so certainly keep an eye out for things that are rough edges or things you might need. I mentioned bulk data being part of a data pipeline, and it's really neat to see that there are increasing open source modules that can work with the data you export using bulk data. Microsoft maintains an open source de-identification tool that reads in bulk data ND-JSON files and outputs bulk data ND-JSON files. So you can kind of slot this in your pipeline to pull out patient identifiers from the data set if the person you're sharing it with should only be getting anonymized data. And it's very configurable in terms of how you mask data and what data you mask. I've been working on a project around assessing data quality in bulk data files. I'm going to actually be talking about it tomorrow at DevDays, so if you're interested, please join us. But that's also intended as a tool that you can put in your data pipeline to get a report on the data quality in your exports and to monitor that over time. So if, for example, a code system changes in your source system, you would be able to understand that the terminologies are different now in your export. We've done some very initial work as a community around a bulk import operation. So the idea here is if you have bulk data and you want to get it into a system, but you want to import it in such a way that you can get feedback on how the import went in a standard way. We've started outlining that in a spec. Unlike the bulk data, don't implement that yet unless you're doing a pilot or some testing. It's really not ready for production use, but if you're interested in that area, please check it out and contribute. Certainly prototypes are worthwhile. In terms of bulk patient matching, I put together a very preliminary proposal like a couple days ago or a couple weeks ago around how we might do this. So if we wanted to use an asynchronous API to match large numbers of patients, kind of taking the FHIR $match operation and saying instead of matching a single patient at a time, what if we wanted to match a couple hundred patients or 1,000 patients at a time? And so some very early work there. So if you're interested in that, please check it out and contribute. Again, not ready for implementation, but really early work. The last early work project I wanted to mention is, and I think Nikolai is talking about this later this week, I forget if it's tomorrow or the next day, is a project that a bunch of folks in the community have started working on called SQL on FHIR, SQL on FHIR. Version 2. And so the goal there is to standardize how you write analytic queries against a FHIR data set that you've loaded into a data warehouse or are operating directly on in ND-JSON. And so I think that's kind of the next step. So we've exported the data, and now we want to do some reporting, do some analytics. It would be great if we can, as a community, come up with some standard ways there so our queries are a little bit more portable. So that's also pretty early stage work. There's a draft spec on GitHub. But certainly an area to contribute to if that's of interest. So I'm gonna leave it there. There are links here to implementation guides, the reference implementation I mentioned. A lot of the work on bulk data happens on Zulip on the FHIR chat. So please join our bulk data stream there if you're interested. And then I have my email there as well. And I tried something new. I put the QR code for the slides and for the feedback here. So feel free to take a screenshot, and I think the slides are also going to be distributed. So lots of ways to get all the URLs in the slides without having to copy them down quickly. So I think we have maybe a couple minutes for questions, if folks have.
Then I wonder about the question how to consider the fact that certain data will not be available when pulling it out from an EHR, so for good reasons. So any thoughts how this will be communicated back, etc.?
Yeah, so if I understand the question correctly, it's you're talking about like sensitive data sets or patients who requested their data not be shared?
There are many reasons.
Yeah, okay. So that's handled a little bit out of band. So basically when, if you were doing, for example, a FHIR REST API request, and there was data that was, for example, like at least in the US, HIV labs are often have special restrictions around them, so they don't come back in the data in your observation data set. The FHIR REST API uses the authorization token to figure out if the user should be getting that data, and then either sends it or doesn't send it. And so we kind of expect systems to use the same mechanism here, where depending on how your app is registered and the tokens associated, how your configurations are associated with that, you'll get back the data that app has the rights to, or the user using that app, but the app registration has the rights to see. So some data may be hidden. And depending, again, on the type of data, you may or may not get back, or you may not, if a server may or may not return an operation outcome saying some data has been excluded. What some EHRs in the US do is kind of have a blanket message that says, some data may have been excluded from this request because they don't want to indicate whether data was excluded. Again, kind of depending on the local rules and the systems involved, you may say data has been excluded or data may have been excluded, or you may just not mention that. Yeah, so that's kind of handled on the auth side, and then the system returns what the user should be getting. Yeah.
Thanks, Dan, for the presentation. I have a question about IPS, because I just came from that talk. I wonder if there's any points of integration or sort of thinking around making IPS and bulk work together?
Yeah, so I have to confess, I have a somewhat US-centric view because I've been working a lot on the EHR certification in the United States, which requires US CDI, which is a slightly different patient data set as I understand it. But I guess from an IPS perspective, there's no technical reason you couldn't kind of transmit those resources via FHIR that comply with those profiles. One of the things we've been talking about for version 3 is whether to have a parameter in bulk data that specifies like the profile set that you want to come back in your bulk data request. So if I'm doing a patient compartment request, I could request data for either a particular set of resources or resources that conform with a particular profile. Currently, that's not in the spec. That could get handled on the server side. So if I'm hitting an IPS server, then I would expect to get back IPS patient records. If I'm hitting a US CDI server, I would expect to get that. But right now, I guess I'm not aware of any specific work on IPS. But I would love to, if someone in the audience is aware, I'd love to know.
Hi, Dan. This ties into your last answer, actually. I was wondering whether there's plans to be able to split files by profile, so you could separate this is lab observations versus vital observations, or in the case of the basic resource, which could contain anything under the sun, and particularly as we start to use it for interversion compatibility, to be able to separate out what kind of content this is. Is that something that's on the drawing board?
It's not something that's kind of been proposed yet, but certainly is the sort of thing seems, at least to me, would make sense to look at for version 3. The one thing I'll add, though, is that there is an extension mechanism where you can kind of add metadata to every file in the output array, as well as to kind of the manifest, the top level manifest. And so if you did want to convey that, like the profile or the category in the case of labs, you could certainly have an extension that did that, and then systems that were able to handle that would be able to take advantage of that, and systems that weren't would just read those as observation files. So that would be an interim mechanism, but I certainly think it's worth looking at like more formal approaches.
Any other questions?
Thank you. I'm just interested in any sort of communication mechanism to state the file expiration date, because I guess the files begin to get stale after a time, right?
Yeah. So in terms of downloading the files specifically, yeah. So there is in the spec an expires header that you can put on your manifest that will tell the client when those files would no longer be available. So particularly with the capability URLs where they're kind of out on the internet, although with high unguessable URLs or high entropy URLs, the system can say I'm only keeping these files up for 24 hours, and it can specify that in the header so the client knows when to retrieve it. The other kind of thing that's a little bit related to that is there's a delete operation that clients can call on the on that URL, the status URL, to indicate that to the server that they've kind of retrieved everything they need to retrieve, and the server can kind of clear the space or take the files off the internet. So there's kind of communication mechanisms on both sides there for the server to say, these files will be up until whatever date, and for the client to be able to say, I no longer need these files.
Okay, time's up, guys. Thank you very much, Dan, for your talk. It was very interesting, and see you around.
Great, thank you.